Servo Motor and very good day. So for today's lecture, we are going to touch the last motor. We are calling this motor as a servo motor. Previously, we learned about two motors, which is the direct current motor, which is DC motor, and the step motor. So this is the last motor in this class that we are going to learn, and we are going to use the Proteus, how to do simulations and understand how it operates. Okay, so servo motor. So for the learning outcomes, very simple. This is how you guys need to understand the concept and how to control the servo motor. Okay, so to be frank, this is the most easiest motor for you to learn and to understand in the Proteus, because this motor only require 3 pins connection, which is only the power, ground, and the signal. So what is RC servo motor? RC servo motor is a servo small device that has an output shaft. So you can see this is a shaft over here. So it is a type of DC motor for position control. You can control the positions of the rotation. Okay, so it is a bit different from stepper, where you are going to change the stepping accordingly by angle. But this one is also you need to change by angle, but it's just a position for 3 angles only. Right? So the shaft can be positioned to specific angular position. You're going to have a very three positions only, which is this position. You have sorry, you have hold on. So this is 90 degree. Sorry. So this is you have this position, you have this position, and you have this position. That's all. All right. So for the RC servo motor unmodified version, we have two types of RC servo motor. This one can only rotate from 0 degree up to 180 degree. Whereas another servo motor, they call it modified. This one can rotate continuously and it looks like a DC servo motor. The operation means that it can rotate like this, very simple. But we are not going to touch this one. In this lecture, we're going to touch about this one. So this is how the servo motor looks like. You can see that here is the one that is going to be rotate, and you can see this is how you're going to look at the degree over here. Maybe you can start here from 0 degree, and you move here to 90 degree, and here to 180 degree. So this is inside the servo motor. Doesn't matter. So this is another type of a servo motor. This is which is insane. But the thing is, the connections only 3 of them, which is only ground and power, and the last one is signal. Okay, so how to control your servo motor for these 3 position? So it's very simple. Before that, the functions. Before we're going to learn about how to control it. So what's the function of it? So you can see that most of the functions is normally for the possibly on the mobile robot. You can see that uh, the, the 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 connections between this one is a servo motor. So it means that the leg can be only up to here movement, maybe up to here, and maybe up to here. That's all. So this is the movement. So you are controlling the mobile robot, and maybe this is a robot, right? So another one is you can control here. This is a servo motor. You can see that here. You are controlling the movement of the leg. So it's going to be in this type of degree only, maybe 90 degree or something like that. So this is the one that you're going to control. So this is another application. This is where you put the shaft to the tap. So it's going to open up the tap automatically. Maybe you want to have a sprinkler system. So you can use this type of applications to open up automatically at any times that you want. All right. So servo motor are used in radio control airplanes to position control surface, control cars, puppets, robots. This is where the servo motor had been used. Okay, so there are difference in terms of sizes and also the torque. Torque is the how much it can rotates the load. I mean that is the torque values. Okay, so how to control that? It's very simple. So what you need to give is a signal. So for this unmodified servo motor, right, so this is going to be 0 to 90 degree, 280 degree, right? So to drive that or to control the RC servo motors, you have to generate a pulse for each 20 milliseconds. So this is a period. Okay, this is period T, which is equivalent to 50 hertz, is needed. This PWM, which is the pulse, must be from 1 to 2 only to control it. For example, you look at this, the first condition, which is at 0 degree. Okay, the whole period, this one is 20 milliseconds. So every time 20 milliseconds completed, there must be a there must be a pulse. This pulse, the value will be only at 1 milliseconds only. Only the high state at 1 milliseconds, and the rest of the states is 19 milliseconds is low. It is 0 volt, and this is 5 volt. By giving this continuous signal, 1 milliseconds and 19 milliseconds, keep on continuous values over here. So you can control a servo motor, which is unmodified servo, to rotate it to the 0 position at the reference here. You can control the motor only to that particular location at 0 degree. To move to 90, okay, from here to here, right? So for example, you want to move from here, going here, you must give another type of signal which is nearly the same, still at 20 milliseconds, but the difference is at the pulse, where the pulse is not 1 milliseconds anymore, the pulse is at 1.5 milliseconds. So again, the pulse is going to be triggered after 20 milliseconds. You can see that this signal is going to be consistently like that. So once you give this signal to the pins at the servo motor, the rotation will go at the 90 degree rotations over here. Right? So the last one, if you want to move to 180 degree from 0 degree to 180 degree, so you have to give the same type of signal, but the PWM now at 2 milliseconds. The period is still the same at 20 milliseconds. So consistently. Okay, so 0 means 0. This is 5 volt. So you can give this signal to any from the digital input output pins. So you can give it from the digital output pins. For example, from port B or port C or port D or port A, you can give the signals. Okay, so the signals will be connected to the pins at the servo motor, which is only one of it, which is this one, orange color. The ground and the red is mainly for the power and ground. Very simple, this is to power up your system. This is to power up the motor, Alright, the practice simulation. It's very simple. You don't have to have a driver anyway. You just need to connect to pins and give the signal, the PWM like we discussed just now. So once you give, for example, this type of signal, your motor will be at this 0 degree location. And if you give this type of signals, you're going to give at 90-degree location, and you give at around 2 milliseconds over 20 milliseconds period, you're going to shift the shaft to 180-degree rotations. So this is only for the unmodified RC servo motor. Okay, so this one I don't want to, this is actually another types of using microcontroller, but doesn't matter. So let's try to simulate the RC servo motor at the Proteus. Okay, the one in the book is using the timer 0 to come up with this type of signal. But today I don't want to teach that particular way, because that way is going to be a tough way, because it involves timer 0. I just want to prove that by having this pulse, we can control our servo motor. Okay, so you are going to your ICs first, and then you have to search for motor servo, right? There are two types of them. So we are going to use the PWM servo motor. This is controlled by PWM that we learned just now. This is no, this is another one. So we are going to take this one, right? So you can drag this one here, and then you connect the center one to the pins here. So I'm going to use pin RB0 as the input for the signals, and the power here and the ground here. So let's go and write the code. So this is your code, right? The main code. Okay, let's declare first your port B, right? Void main. You trace B is equivalent to 0B, 0, 0, 0, 0, 0, 0, 0, 0. Okay, you are giving all the port B as the output to give the signals. And the condition voltage for port B initially at all 0 volt. Then you have this while one loop, for example, and you are going to have a continuous loop over here. So what we are going to do is, in this loop, we are going to have a signals from port B, that particular pins. Alright, so here you can try to generate a signal like this, going up and down here. This is 1 milliseconds. This is totally 19 milliseconds. And the total value here is 20 milliseconds. So you have to give 5 volt first at the output, and then later you are going to have this one, right? So after this, you are going to have a continuous, which is a looping here. So what you can do in the program, very simple. I just want to show you how you're going to do that. So what pin that we are using right now at ICs, this is port B RF0. Okay, so now in this loop, we can give a signal 5 volt, port B dot F0 is equivalent to 1, right? It's going to be up, and then the delay for this 5 volt is 1 milliseconds. So you can remember that we are using delay MS, only 1 milliseconds, and then after that 1 millisecond, you're going to pull down the pin port B dot F0 equivalent to 0 volt, and the delay will be 19 seconds. Okay, so you have this one. So if you read this code, right, the first one you declare the port B and the initial value for port B, then you will go to the loop here. The value for port B F0, which is at this one, F0 will be top one, first will be up 5 volt for 1 milliseconds, and later is going to have a 0 volt for 90 milliseconds. After this one completed, you will go back to this while one loop, and it's going to be continuously giving a pulse of 1 milliseconds over 20 milliseconds period. Okay, so let's compile this one first. Is there any problem or not? So there's no problem. As usual, you can just go directly. This is my project just now. I haven't changed this one to 20 megahertz. So let's look at the timestamp. It's 18 p.m. Just okay, and then we run it. You can see that my servo motor is changing the direction. This is the 0-degree directions. Do not look at this one. This is just a reference based on particular servo motor. So we are going to look at the signals generated. You can go to the oscilloscope here. Then we're going to look at the output from this pin. Let's run. So you can see that this is the value of it. So let's try to all right. So okay, you can see that this is how many of them. So we are going to calculate this one. So this is the last one, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 squares, which is going to be 20 milliseconds, right? To 20 milliseconds. So one of them is 1. This is around 1 milliseconds or something like that. So it's okay. Let's look at the result here. So this is around 1 milliseconds, and you can see that the result is like this. So I'm going to change it to DC. This is much better. And you can stop. I think you can stop this channel anyway. Let me try to look at the stop. I'm not really sure that I can find it. Oh, this is one shot. So you can see that okay, just you can try to calculate based on this the knob that over here 5 means that one of the square will be having 5 milliseconds, right? So total here 1, 2, 3, 4. Starting from here 1, 2, 3, 4. 4 times 5 is 20 milliseconds. So this is roughly 1 milliseconds. So because of these signals you are generating, and you can control the servo motor to 0-degree positions. Okay, just a quick note. I understand that some of you may have problems if you accidentally delete this one and you don't know when you run this one again, you cannot see the oscilloscope anymore. But doesn't matter. You just go to this debug and then you turn on back your digital oscilloscope. That's all. So if you accidentally close the reading for the oscilloscope, you can turn on it back by using the debug drop down over here and then go for digital oscilloscope. Okay, so that's the first value that we can control. Let's try to control another one by looking at the command just now. So I don't want to go for 1.5 here because right now, just now in our code, this is 1 milliseconds, right? We don't have 1.5. We don't have 1.5 here. We are not allowed to do that. There will be a problem here. See, there's a problem. It must have an integer. So I'm going to use 1 and 19 first. So we are going to look at the second one. The second value is this one, 2 milliseconds over 200 milliseconds, which is 2 and 18. So you go back to your here, you can go to 2, this one 2, and then this one 18. So 18 plus 2 is going to be 20, right? So you just save this one project and build this one again. All right. So let's look at the results. So just now is 90 degree, negative 90 degree. That this is just now, if you can remember that just now, when we put this position, the position is actually at negative 90 degree. All right, so the new one, let's run it. So you can see that it's moving to 90 degree plus. So let's look at the debug digital oscilloscope here. You can see that the results now is more than 1 compared to just now, this is 2 milliseconds already. You can just one shot here. You can see that this is nearly around 2 milliseconds. And now it's 90 degree, right? So from 90, negative 90 to 0, and then to plus 90, total will be 180 degree. So it's correct, where our comment just now that if you put 2 milliseconds over 20 milliseconds period, so you're going to control it around 180 degree. So this is correct. Okay, so how to have this one, 1.5 milliseconds. Okay, let's go back to the code here. So you have delay milliseconds. Can you find out any delay? And also just go to the help over here. Let me double check the help over here. Okay. So the help here, just go for this delay index, right? This one. Delay, sorry. So you can see that there are 3 types of delay. Delay cycles, delay ms, delay microseconds. So what is microseconds? Milli and micro. So you can use this micro now. So this is again, delay microseconds is 1000. Is 1 millisecond. So 1000 is equivalent to 1 milliseconds. 1000. So what we are going to have right now is in our signal generation is 1.5 milliseconds. So 1.5 means millisecond is going to be 1500 milliseconds. So let's try to use this one at the micro C here. Instead of milli, we are going to use U here. So 1.5 millisecond is equivalent to 1500, and the total up to 20 milliseconds will be around, let's just 1500 minus, this is going to be, is it going to be 15, 2000, 20,000 minus 1500. This is going to be 18,500. So is it correct? It should be correct. This is 18,500 plus this one is going to be 20,000, which is 20 milliseconds. So, okay, let's try to run this one, build. And then you can run back at this Proteus. So it at particular 0 position. Just remember just now the first one we have is 90 degree, negative here, and then it go to here from negative 90, go to 0 degree, and go to 180 degrees. So it's correct. This is a, sorry, this is a 90 degrees, sorry. It's not 90. So total here is 180 degree, which is correct. So you can see that this is at 0 degree. So the signals is, let's look at the signals here. Debug here, go to digital oscilloscope. This is the signals, it's around 1.5 milliseconds. Okay, so okay, let's try to have another way of looking the differences on the rotation. So I need to teach you guys how to write a code by using a function or subroutine. So okay, so I'm going to take this one out first. So this is the normal one, right? That one that you have. So if you want to write down a code by using subroutine or function, you can create another void function over here. So this is void. You must go back to remember. You must go back and remember your C++. You just create a function. This is maybe 0 degree. this is 90 degree. Okay, servo, which is just now, just remember that this is, I refer this one is, I refer this one at particular 0 degree position. This is at 90 degree position, and this is at 180 degree position. So I'm going to use the name here, but the position on the Proteus is going to choose, is going to have this number. Okay, I'm going to use this as my number, right? So the servo void servo motor 90 degree function is this one. So you're going to have its function. What it's going to do is this one. So this is the 90 degree. So I'm going to create another two more, which is 0 degree and 180 degree. So I'm going to change this. Just copy this one. Should be much easier. And here. So this is going to be 0 degree. So 0 degree just now must be milliseconds. Remember that, milliseconds and milliseconds. And also 90 degrees. This is going to be 180 degree. I'm going to change this to milliseconds and also milliseconds. Right, this is going to be milliseconds 1/19. This is going to be 2/18. Alright, now you have these functions. So is it any problem? Just build first. So no problem so far. So inside your main program, you can call this function because you created the function outside from your main body. So you can try to run this function one by one. So let's try to take this one, servo motor, here. Then you have here. Then you have here, the last one here. Do not take the void. The void is just the name of the function. What's the type of the functions. So this is the one. So if you run this one, it's going to be very fast. Okay, doesn't matter. Let's try to just run this one. Build fast. Build first this one. If you run the code, so it's very fast. You cannot see it. So because it's very fast, you cannot see it. So we have to put a delay. So after you have this function done, so we're going to put a delay ms, maybe 1 second. Same goes to this one. And same goes to this one. So let's try to have a look at the results. Zero degree, 90 degree, 180 degree, and go back to 0, 90 degree, 180, go back to 0. So you can see that this is how we control the positions of the RC servo motor, which is the unmodified version. Only three positions that it has. We can call it from 0 reference, then 90 degree, then 180 degree. So this is how the signals that you generate. You can generate like this. So inside the book that we have for the microcontroller technology book, we are using timer 0, which is different method, but the method also can give exactly the same pulse width modulation like what we have just now. So I want to show you guys a very simple method. So that one I'm going to touch it maybe on the last lecture, which is going to be this week or next week before we're going to our midterm. So at the moment, I'm going to have this particular method to teach you guys how to control a servo motor. So it's proven, right? From 0 to 90 degree to 180 degree. By having the signals, let's look at the signals here. Okay, do not forget to look at the signals. You can see the difference because it's very fast. Small, Yeah. So you cannot see it because it's very fast. That's why if this is not really a good so just to show that the oscilloscope that we have, but you have to change this one accordingly to sample the time. Alright, so this is how we are controlling the servo motor. So back to the slides, I think that's all that I want to teach for this time of lecture, because that's the only thing that we need to know about the servo motor at the moment. So to recap, so far we have learned three types of motor. So you can see that if you put side by side, all these three motors, they have different functions and they have different types of controlling it. So you have to remember how to control it. You have to know how to control these types of motor, and you have to know what's the differences between them. For example, DC motor, you can control the degree of it. You just need to rotate it as well. But for stepper motor, it's quite precise and accurate, where you can move the motor position up to the level that you want to do accordingly based on the step angle on the specs of the stepper motor. And the last one for the RC servo motor, it has around 0, 90 to 180 degrees. So this is the position that it can control. So more or less, you can see that this is how uh, the differences on the motor itself. So I think that's all. Thanks. That's all for today's lecture. So do not forget the assessment. I think this round assessment will be done in the Ulearn back, because there might be a problem in Microsoft Teams, because I saw some things over here. It's going to be open and announced later. But all the best for you guys. Hopefully that this lecture is work fun for you guys. Thank you very much.